A pleasant morning, everyone. By the way, we are now in, I think this is lecture 5 about alcohols, ethers, and thiols. So once again, good morning. We are going to discuss this topic, which has something to do with alcohols, ethers, and thiols. So in this chapter, we are going to study, of course, the physical and the chemical properties of alcohols, ethers. These two are containing oxygen containing organic compounds, that alcohol. And alcohol has a functional group of ROH, while ether has a functional group of R, and that R is R1, R prime, no? R, then O, then R double prime. Okay, meaning that R1 there or R prime there is another type of an alkyl group, and the R2 prime is another alkyl group. Okay, so this is what we are going to discuss this morning. So we will also include thiols. What are thiols? These thiols are sulfur containing compounds, okay, which is almost the same with the structure of an ether or an alcohol mostly. But what happened here is it is with the presence of S or sulfur. Okay, instead of OH, it will be SH like that. So as you can see here, this first one is an alcohol. This is an alcohol. It is ethanol. Okay, ethanol. Later on, you will be guided on the naming of the alcohol, how it is being named. It's almost the same with the alkane, alkene later on. This is an alcohol. This is an ether. As I have said, this is an R1, R prime 1, and this is R prime, R double prime, R prime, then R double prime. So this is, which is being attached with the oxygen. As I've said, these are oxygen-containing organic compounds, okay? This alcohol and ethers. So that is diethyl. This one is named as ethanol or ethyl alcohol. It's the common name, ethyl alcohol. The parent name here is an ethane. Then there is an OH here. So that is why it's so-called ethanol, okay? This one is ethane thiol. Instead of OH here, this is being replaced by S. So this S here are the thiol, okay? It is a thiol. So what are the structures, names, and physical properties of an alcohol? Let us start first with the structure. So of course, as I have said, the functional group that can be found in the alcohol is R, then OH. The OH there is known as the hydroxyl group. This is bonded to the carbon, the tetrahedral carbon atom. So here it is it. This is how you can see this. This is the carbon tetrahedral. Why tetrahedral? Because this could be banded into four, no? Four groups, no? Or four attachment could be in the four attachment. So this is carbon at the center, then H, then you have now ROH, no? So this is an example of an alcohol, the easiest one, which is known as the methanol or the methyl alcohol. No? So this is the Lewis structure of our methanol. So this is your carbon. That white there are the hydrogen, and the red one here is the oxygen. And it has this angle here is 108.6 degrees. No? And close to tetrahedral. This is close to tetrahedral. tetrahedral has an angle of 109.5 degrees. Okay. So how are we going to name this? In the IUPAC system, it is the same as the alkenes and the alkynes. What is being changed is instead of ending with E, no, if it is alkane, it ends with E. No? Here it will end with all because alcohol, all. Okay. The ending here, all, tells us that the compound is an alcohol. So what is the rule? Of course, same thing. Let us select the longest carbon chain that contains the OH group. So you should select the OH, no? The longest continuous carbon chain that has the OH as the parent alkane, no? And number it from the end that gives the OH the lower number. Always remember, same thing with other compounds that we had been doing, no? We should select the OH where it is being attached. The OH is being attached. You should select the lowest number, okay, in naming its parent chain. So the location of OH group takes this precedence over alkyl groups, aryl groups, and halogens. Okay, so what will come first, of course, will be your OH before other groups. What are these other groups? The alkyl groups and the halogen groups. Okay, alkyl, the aryl, and the halogen groups. So, as I have said, you are going to change the parent alkane from E to all. But for cyclic alcohol, what will happen? The OH bearing group will automatically number as 1. Okay, so your OH for the cyclic group, the OH there will bear carbon 1. Okay, then name the number of other substituents, and list them in alphabetical order. Same thing. Other substituents should have the alphabetical order. If it is ethyl, methyl, benzyl, oh, you should start with B, benzyl, or followed by ethyl, then methyl. So it should be in alphabetical order, the substituent or the attachment. So derive the common, there are no common names for alcohol aside from the IUPAC, but only few of this alcohol has a common name. Okay, so in most cases, what is being followed always is the IUPAC name. So that IUPAC name are in parentheses, no? Here in this example, the IUPAC are in the upper portion and the parentheses are the common names. There are only 8 of this alcohol with a lower molecular weight which has a common name. Let us see what are those. So here, this is now ethyl alcohol. Okay, kanimo ni ang common name in parentheses. No? And its IUPAC name is ethanol. No? Ethyl alcohol or ethanol. No? Then this one is how many carbon? How many carbons are there in ethanol? There are 2. That is, you should not count here as 1. Dili nga na mag-count of 1 ha. That is 1, 2. Okay. Here, you should count here as 1. 1, 2, 3. So that is propane. So take away the E and the propane, then exchange it with all. And where can you find the OH? It is in carbon 1. Therefore, that is 1-propanol for the IUPAC name. And for its common name, that is propyl alcohol. Okay, that is it. Then this is now our isopropyl. Now, isopropyl alcohol. Isopropyl alcohol is in the IUPAC name as 2-propanol. Why 2-propanol? Okay, this is carbon 1, carbon 2, and carbon 3. Where is our OH? It is in carbon 2. That is why it's so-called 2-propanol. Mao din na isopropyl, ma'am. Yes, that is isopropyl alcohol. Mao di ay ning ethyl alcohol. Yes, that is ethanol. Okay. But this one have different sources. This one, that isopropyl alcohol, is a byproduct from the crude oil. Okay. This one, ethyl alcohol, is the byproduct from the what? It is in the sugar cane. Nang lahi silang source. But they have almost the same use. That is for disinfectant. Okay. And this is now butanol. 1-butanol. Why? Naama siya sa 1. Asa ta mag-count? This is 1, 2, 3, 4. Dili nga niya mag-count kay kung nga na 1, 2, 3, 4, 5 sayop na. This is it because this is being branched with OH. Okay. Here in carbon 1. That is 1, 2, 3, 4. So the parent is butane. Take away the E and change it with all. Therefore, that is butanol. Where can you find the OH group? It is in carbon 1. Therefore, that is 1-butanol. If it is here, meaning it is 2-butanol. And that is secondary butyl alcohol in the common name. The sec-butyl alcohol. Then we have here the isobutyl alcohol. Where can we find the alcohol? It is in 1, but there is a substituent. There is a substituent at carbon 2. This is the parent. Let us get first the parent. 1, 2, 3. So it's propane. Take away the E, add all. Propanol. Where is our OH? In carbon 1, but we have a branching, a substituent of methyl. Where is methyl? At 2. That is why it's so called 2-methyl-1-propanol for the IUPAC, or isobutyl alcohol in the common name. Here, the common name here is tertiary butyl alcohol. Okay, this is how many? No? Tertiary. What is its? No? What is its? By the way, this is how many carbon? Ngan pwede ka nga ni 1, no? Di sabi, di ba? 1, 2, no? That is propane, methane, ethane, propane. So, tulo na siya. 1, 2, 3. Like that. Na? Kanilahi siya. Kaya nga na ang attachment count na kag 1. Okay, that is 1. No? This is 1, 1, 2, 3. Okay, so sa 2, naa siya methyl, no? Naa siya methyl. That is here. 1, 2, 3. Ana di ay? 1, 2, 3. Okay. So our OH here is on carbon 2. That is 1, 2, 3. Like that. Huh? Therefore, 1, 2, into there is our propanol, the all, no? And we have also methyl. Therefore, that is 2-methyl, 2-propanol, and that is tertiary butyl alcohol for its common name. And this is a cyclo, no? Cyclohexane. Why? Because it has 6 sides. No? That's 1, 2, 3, 4, 5, 6. Di ba ang sa isulti? Kung asa ang OH, that will always have carbon that will be numbered as carbon 1. Therefore, this is cyclohexanol or cyclohexane. hexyl alcohol. Okay. So here are some examples. Let us try to name this. Okay, this first one. What is the rule? No, you should select where your OH nearest, no, to carbon 1. Okay, so if we will have this as carbon 1, 1, 2, 3, 4, 5. Okay, first thing is get the what? The parent. It's 5. Okay, meaning it is pentane. Okay, so take away the E, it will be all. So pentanol. But where can we find our OH? We should not have this as carbon 1 because if we will have this as carbon 1, therefore our OH will be what carbon? 1, 2, 3, 4. Na as a 4. But if we will have this as carbon 1 here, our OH will be carbon 2. Therefore, it is now 2, no? 2 pentanol. But there is a substituent at carbon 1, 2, 3, 4. There is 4 methyl. Therefore, finally, its name is 4 methyl 2 pentanol. Okay? Oh, that's it. So 4 methyl 2 pentanol. Here, this one. We already know that this is a cyclohexanol. No? This is a cyclohexanol and we have methyl here. Sayop ni siya nga trans ha, dili ni siya trans. You can read trans, it is opposite. It is, di ba? We have ortho, meta, okay, para. So we can name this as O-methyl, O-methyl cyclohexanol. Or we can have this, as I have said, the OH bears carbon 1. 1, 2. This is methyl. No? So therefore, it will be 2-methyl cyclohexanol, or it is what? Ortho, you can have it ortho methyl cyclohexanol. So that is how you are going to name an alcohol. So this one will be your assignment. Okay, I'm going to have this in our LMS for your assignment. So let us proceed now. Actually, alcohols are being classified into 3. That is the primary, here. This is how it being symbolizes with the primary, secondary, and tertiary. Okay, you should know how to identify primary, secondary, tertiary alcohol because this is very important in knowing the reaction mechanism. Because primary, secondary, and tertiary alcohol will differ in the reaction, in its reaction mechanism, or in its product. No? Lahi ang primary, lahi, though they have the same, okay, process in the reaction, but what will happen is they will have the different product. Okay, so you should know what is primary, secondary, and tertiary. This will be known by where your carbon is being bonded with your OH group. Okay. And that way we can classify it as primary, secondary, and tertiary. So we have here an example. Okay. Which one is the primary, the secondary, and the tertiary? Okay. Okay. This one is known as primary because this is directly your CH2 here, or your C. No? If you are going to have that is C, then diba, H, then OH. This is directly bonded to your carbon. Basta directly bonded to your carbon, that is primary. Your OH is directly bonded to your carbon. It is primary. Secondary is, no, in your secondary, what happened here is your carbon here has how many? Kani, pila ka buok yung substituent. Kani is, your carbon here is, though it is bonded, no, but not directly to your carbon. Dili largo, no. Here, naapay C, then H, ibabaw H, then we have here, no, then OH. Unlike here, oops, unlike here, it is in the second portion wherein your carbon is being bonded. Why? Because, di ba, this is CH3, no, kani, CH3, sunod CH, no, CH, then OH. Sa kaduha pa siya, ikaduha, no, siya. Here it is directly bonded. So this is secondary. In tertiary, what happened? Your OH is in the carbon 1, carbon 2. Then, kompleto ni siya with the OH, with the CH3, with the substituent nga imong attachment here, no? Therefore, this is tertiary, okay? That is the difference between the primary, secondary, and tertiary, okay, carbon. So here, you're going to answer this as an assignment. Again, I'm going to send this with your LMS. Okay. So in the IUPAC system, also, in case there will two hydroxy group, the OH2 OH group, they could be named as diol. Diol. If there are three, triol, so on and so forth. If there will be four, that will be tetra, tet, tet, tetrayol. Ano? Not that tetra, the tetrayol. Diol, triol, and tetrayol. Okay, that is it. No? If and when there will be two OH, hydroxyl group, diol, three, triol, four, tetrayol. Okay, so the IUPAC names for diols, triols, and so on, of course, same thing. Kwaon ang E in the name of the parent alkane, then you retained the all, that diol. Instead of all, it will be diol, triol. Diba? All on that to. So, but you're going to place now, where is your diol? Nah? What particular number in the carbon chain? So, if it is ethane diol, meaning 1,2-ethane diol, for example, like this, no? Compounds containing two hydroxyl groups on adjacent carbon are often referred to as glycols. So, lain po ng glycols, lain po ng diols. Okay. So, this is pila ka buok OH. This is OH here, OH. So, in 1, 2. What is your parent name? Ethane. Then, 1, 2 ethane. Then, you place diol. So, that is 1, 2 ethane diol, or the common name of this is ethylene glycol. Here we have, it's a propane, that is 1, 2, 3. But what happened here is there is OH at carbon 1 and another OH at carbon 2. Therefore, that is 1, 2. And what is your parent? It's propane. Take away the E in propane, then you exchange it with diol. Okay, that is propane diol. Okay, propane diol. Okay, that is it. Or the name of this is propylene glycol. And the last one is if there are three OH, okay, in a propane. Therefore, that is 1, 2, 3 propane triol. And this is now glycerol or glycerin. What are glycerin, by the way? This is very common. No? polar solvent in water. That is ethylene glycol, no? It could easily dissolve in water. And kaning glycerin is the one which is being used as an add-ons for making your hair soft, no? In the making of the shampoo. So that's glycerin. Okay, so that's it. What are the physical properties now of alcohol? So the most important physical properties of alcohol is with their polarity. How will you know it's polar? Because of the presence of the OH group. So here, your oxygen and carbon and at the same time oxygen and hydrogen, both CO and OH. No, because of this presence of the oxygen, the CO and the OH, both of them are considered as polar molecules. No, polar molecules or polar covalent. Nga naman, because they could form a hydrogen bond. Basta na gani oxygen, na CO and OH, of course, they are considered as polar molecules. Why? Because they could form into a hydrogen bond here. Tawa ni siya. So the polarity of COH bonds in methanol, that's methanol. So if you can see here, your carbon and oxygen, your carbon could bond to another hydrogen, diba? So that is partially positive. Your oxygen could bond to another hydrogen. It's partially negative. And they are covalent, covalent bond. Why? Because this could form into hydrogen bonding. Okay, no? One of the example of diols, for instance, we have nitroglycerin is used as an explosive at the same time a drug. Okay, it was Ascanio Sobrero who discovered this. What is that nitroglycerin? Nitroglycerin has a formula of 1,2,3 propane triol, or that is known as glycerol or glycerin. As I have said, katong ginabutang po sa shampoo, that is one of its uses to make your hair soft. Okay, no? But another thing, it could be used as an explosive. When will it be used as explosive? When this is being added, when it reacts with nitric acid, this one, in the presence of sulfuric acid, this will give a nitroglycerin. And that nitroglycerin is a yellow liquid. No? And this is used as explosive. In what way? So nitroglycerin are now used as blasting agent, for construction canals, tunnels, roads, mines, or in short, usa ni siya, mga dynamite. Even in fishing, ginahimo na ni siya, no? So, unsay naasulod sa dynamite, it is nitroglycerin, no? Pero usa ka problema sa nitroglycerin was it's difficult to handle safely. Nga naman, once it is accidentally added, basta gani muinit lang siya gamay, what will happen? This will explode. So what happened is it was Nobel. Wow, it's Alfred Nobel who discovered that this nitroglycerin, which is a diatomaceous earth, once it will be covered with a clay-like substance, okay, and na-fuse, what happened? This will not explode dayon. Kita ka mga dynamite, okay, so that dynamite, inside that dynamite, It's a clay-like substance. Clay, giputos ang nitroglycerin. Nitroglycerin is inside that clay-like substance. Tapos gibot na mag-fuse. What do you mean mag-fuse? Diba ka na magdagkutan? Mura magkandila. Okay. Na-fuse na siya. So, as I have said, the problem with nitroglycerin, once it will increase its temperature, it will explode. So, gibuhat nila, they place it with a clay-like substance. So, dili siya basta-basta ma-explode. No? Kaya naman, di man mo saka yan temperature. Controlled yan temperature. Pero na-fuse. Okay. Katong fuse, mo ito'y dagkutan mo, bitaw dagkutan to siya. Pag dagkot, syempre, mo init, that is connected, that fuse is connected, no? To inside of that clay-like substance with the nitroglycerin. What will happen? Of course, katong nitroglycerin, mubukal-bukal na to, muinit. Pag init, una na ito siya mo, boom. That's it. That is now the dynamite. Okay. What is the dynamite? Dynamite is a nitroglycerin. Where, how it is being made? From the 1,2,3 propane triol or the glycerol or the glycerin. Then, added with nitric acid in the presence of sulfuric acid, you will form now the 1,2,3 propane triol trinitrate, or known as the nitroglycerin, which is the main component of dynamite. What are its uses? Kani siya, no? Kanang pasabugon ang mga, no? Okay. For instance, it's in the making of, what they call this, in the making of tunnels, sempre, in making of canals, daghan man siya mga debris. Aron mawa ang mga debris, ilang kuanan og dynamite. Pagsabog, mga gagmay na dayon to. That's it. That is the use of your nitroglycerin. Okay. But not only for explosive, no? So the nitroglycerin is available in the liquid form. Okay. No? So diluted in alcohol in order that this will not explode, no? Kung pwede siya in a form of what you call this liquid, pero i-dilute yun na siya with alcohol aron dili siya mo explode, no? So, and no, basta naanaga na siya diluted with alcohol, it is no longer explosive. It is non-explosive. And this is used in drugs. In what way? The tablet form, paste form, relaxes the muscles, smooth muscles of the blood vessels, causing dilation to coronary artery. So, kinahanglan, ginabutang po nis medicine, no? As an intake. Why? Mulapot na gani ang dugo sa artery, what will happen? Maglisod na siya og, no? Pass sa artery. So, kinahanglan na siya i-dilute. So, the one that dilutes it helps in diluting this coagulated blood. What will happen? Blood vessel, in the blood vessel, it is now the nitroglycerin. Okay, so double purpose siya, no? And it was, no? Wala pa, ang nabalaan ra ni Alfred Nobel is for, no, for diffusing the explosive, no, by placing it in a clay substance, di ba? Sa iya. Pero he never know nga this could also be used in dilation of the blood vessel in the coronary artery. When Nobel becomes ill with heart disease, his physician advised him to take nitroglycerin to relieve his chest pain. Pero sa may nahitabo, dua siya. Kaya naman, ingon siya, wala siya kabalo kung unsa pag effect. But after 100 years, patay na siya. It was found out that this nitric oxide, no, derived from the nitro group of nitroglycerin, relieves now pain chest. So that is the beauty of, yes, the beauty of these chemicals. Na? And that is coming from the hydroxyl group, the OH group. Okay, the tulo, the triol. Okay, so here, so this is nitroglycerin is more stable when absorbed in inert solid. So ginabutang yun na siya in between, the what they call gina sandwich, no, in an inert solid or a clay. Okay, like so, that is dynamite. It was Alfred Nobel. Okay, if you look into the structural formula of lower, no, lower alcohols, this is methanol. What is its molecular weight? That is 32. Boiling point 65. No? Its solubility in water, it is infinite, meaning very soluble siya sa water. Then this one is what? Ethane. Pero ethane, compare ni mo ha, gamay ra sila og molecular weight sa methanol is 32, molecular weight sa ethane is 30. But its boiling point is negative 89. Least dugay. Ubus kayo siya og temperature sa boiling point. And it is insoluble. We have ethanol, no? Molecular weight 46. Its boiling point is 78. That's ethanol. It is still very soluble in water. Then one, propane, which is an alkane, dili siya. No? Halos pareho na siya molecular weight, but it is insoluble. Why? Nga naman, kani walay OH, di ba? So meaning this could not form into a hydrogen bonding. Okay. Then we have one propanol, 60 molecular weight, 97 ang iyang boiling point. Then, infinite pagyapon ang iyang solubility in water. But, as you can see here, as the number of carbon increases in the alcohol, what happened? Its the boiling point will lower. And its solubility in water lisod na. Mostly are insoluble. It will start with na butanol. Gamay na lang, na. So in butanol pila taas ang yang temperature. Propanol ni ha, butanol. Pero ang butane, na tan-aw nimong ethane, na ethane, propane, butane, puro gyud na siya insoluble in water, no? Then that is butanol. Ang butanol, it's no longer infinite in solubility. Naa na siya particular. In 8 grams, it needs 100 grams of water. Like that, no? So, as you can see here with the alcohol, as the number of carbons increases, its solubility also in water decreases. It is incomparable with the alkane. Ang alkane is by nature insoluble in water. Okay? So, alcohols have higher boiling points than do alkanes, alkenes, and alkynes with similar molecular weight because alcohol molecules associate with another liquid state by hydrogen bonding. So it's really the hydrogen bonding that makes your alcohol, no, have a higher boiling point and at the same time have a solubility in water. No? Why it is soluble in water? Because of hydrogen bonding. So because of the increase in London dispersion forces between larger molecules, the boiling points of all types of compounds, including alcohols, increases with increasing molecular weight. Tanawa nga niya. Pero kutob rata sa butanol. Methanol, na 65. Then ethanol, 78 degrees centigrade. Then propanol 97, butanol 117. Why? Because also of London dispersion. No? At the same time, by hydrogen bonding. Okay, these are the two reasons why alcohol with a lower number of carbon have higher boiling point. It increases with number of carbon and its solubility because of these two reasons: the hydrogen bonding and the London dispersion force. So that is hydrogen bonding. Okay, that one there. The association of ethanol molecule in liquid state, the OH, can participate into three hydrogen bonds. So one through hydrogen and two through oxygen. Now, so only two of these three possible hydrogen bonds per molecule can be seen here. Okay, the kinesia. No? So three hydrogen bonds in ethanol. Okay. So as molecular weight increases, the water solubility of alcohol becomes more like of hydrocarbons. Bali siya ha? As a molecular weight increases, the water solubility of alcohols become more like hydrocarbons. Magka gamay po yan solubility in water. No? Higher molecular weight alcohols are much less soluble in water because of the size of the hydrocarbons of in their molecules. Mudako na gani ang size CH3, CH2, 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 ana, what will happen? This will decrease its water solubility. So, becomes so large relative to the size of the OH. So, which increases water solubility. Kung gamay ra, no, what will happen? Your OH is relative to your, no, to your CH group. Kung gamay-gamay ra, no? So, this will increase its solubility in water. So, what are the characteristics and reaction of alcohols? No? In most cases, we will only have three, no? Four reactions. Wherein the first one, when alcohol is dehydrated, no? That is when alkenes, no? Bali man na siya. When alkenes is added with water, na? Okay. When alkenes is added with water, you will form alcohol, di ba? Okay. When alcohol is dehydrated, meaning gikuhaan og H2O, you will, what will happen? This will form back to an alkene. Another thing is when alcohol is oxidized, this will form into either, kanina insultin ako sa inyo, na importante that you can identify its primary, secondary, and tertiary. Why? So, when alcohol is being oxidized, if it is a primary alcohol, this will have a product of an aldehyde. If it is a secondary, it will have a product of ketones. If it is a tertiary, it will have a product of carboxylic acid. Okay, that's it. So those are the characteristics of alcohols in its reaction. The first one, let us have now the acidity of alcohols. No? So alcohols have a pKa value of almost the pKa values of water, which means that aqueous solutions of alcohols have approximately the same pH as that of water. No? Pareha siya pH value. What's the pH value of water? It's 7. Okay, so neutral ni alcohol. Okay, so phenols, pero lahi ang phenols. Phenols, what are phenols? Diba? That is benzene ring with OH. Okay, that's phenols. Phenols are weak acid and react with aqueous sodium hydroxide to form water-soluble salt. reana. So this is a phenol. This a benzene ring with OH. When it is being reacted with sodium hydroxide, what happened? This, in the presence of water, this will give you a water-soluble salt, which is a sodium phenoxide. This is a water-soluble salt and water. Okay, what happened? This OH here will cleave with your hydrogen here to form into H2O, and your Na here, your sodium, will cleave with your O here to form a sodium phenoxide. That is in the acidity of phenols. Okay, so alcohols are considerably weaker acid than phenols and do not react in the same manner. Ano man, because phenols are weak acid, while most of alcohols has almost the same pH with pure water. Its acid catalysts dehydration of alcohol. So let us have now the dehydration. What is the meaning of dehydration? Meaning you are going to take away the water molecule. Okay, so here elimination of molecule of water from an alcohol. So in the dehydration of an alcohol, what happened? OH is removed from one carbon and H is removed from the adjacent carbon. Always remember that. Okay, that your no OH is removed from one carbon and hydrogen is removed from the adjacent. Adjacent meaning ang iyang atbang or oh, next. That's the adjacent. Next, no, the next one is the adjacent carbon. Okay. So in the laboratory, dehydration of alcohol is most often brought by heating it with 85% phosphoric acid or concentrated sulfuric acid. So these are its no, these are its reaction. First, let us start with primary alcohol. So primary alcohol is the most difficult to dehydrate. No? So it needs a higher temperature and with the addition of sulfuric acid. Dumduma ha? Basta primary gani, lisod siya i-dehydrate. So, aron ma-dehydrate siya, you should have a higher temperature. No? About 180 degrees, and you need to have sulfuric acid add on. Okay. For instance, we have ethanol here. Take a look. Ethanol here, no? What happened? We add it with our reactant. We have the sulfuric acid and a very high temperature, 180. The process here is dehydro, dehydro, that dehydration. What is dehydration? Getting the water molecule out of its reaction. Okay. So here, unsa to? Makuha ang usa ka OH kini, di ba? Makuha ang hydrogen here, OH. Then makuha ang usa ka hydrogen adjacent to this carbon. Where is adjacent? Sa ani. Kanina, na the OH will be taken out and the H on the adjacent carbon will combine with your OH to form H2O. So what happened here? You have CH2 na ni siya. Then that will be converted into an alkene. Na? I repeat, the primary is an alcohol. Primary alcohol, what will happen? In the dehydration process, you will form an alkene and water. So this is now an alkene and water. So your OH will combine with your hydrogen on the adjacent carbon. Okay, where your hydrogen, the OH is connected. Therefore, you will form now an alkene and water, because in dehydration you will remove water in your alcohol only if your alcohol is in a primary alcohol. Okay? So how about secondary? Same process, dehydration. No? Take a look. Here, the temperature is 180 degrees. Ano man, lisod dehydration, no? Ang primary compared with the secondary. So this is now our secondary. We have cyclohexanol. We have the same catalyst, the sulfuric acid. But take a look. Our temperature here is from 180. Here we have now 140. Ha? Same gihapon. Your OH will be saman. Makuha ang OH. Then, kaning usa ka hydrogen nga niya makuha. Therefore, it will now form into an alkene, a cycloalkene. So that is cyclohexene plus water. No, that is for the secondary. They have the same catalyst, sulfuric acid, but they will differ in the temperature. For the tertiary alcohol, what happened? Same process, this will undergo dehydration and the temperature will be lower. Okay, so here that is the tertiary butyl alcohol. No? So we have sulfuric acid and 50 degrees centigrade. What happened? Diba, mao ni ang OH? Okay. Your OH makuha, then the adjacent. Asa mga adjacent mga bata? Kanang nganhia, kani. Kani. Adjacent mo ni. Adjacent sa imong carbon nganhia. Kani. Makuha usa ka hydrogen. Na? To form into H2O. Then, this will be converted into an alkene. Therefore, this is 2-methyl propene. That is for the tertiary. Primary, secondary, tertiary. It is easier to have the process of dehydration in the tertiary, followed by the secondary, and pinakalisod is ang primary. Okay? No, you need to have a higher temperature in dealing with the dehydration of primary alcohol. Okay, so the is in dehydration of alcohol, it is na easy, no? It is easy to what? Dehydration. It is easy to have it in pinakalisod ang primary, sunod secondary, pinakasayon ang tertiary. Okay, so this is the is in acid catalyst dehydration in the alcohol, na primary, secondary, and tertiary. No? So when the acid catalyzed dehydration of an alcohol yields isomeric alkenes, dumduman ninyo ha, ang alkenes, ang iyang product. No? So having the greater number of alkyl groups on the double bond generally predominates. What do you call this? What do you mean by predominates? It has a greater chance in having that product compared with less number of alkyl group. The greater the number of alkyl group in the double bond, the greater will be the reaction to proceed. Okay, for instance, here we have 2-butanol. Okay, 2-butanol, we have same, basta dehydration gani, duha ra gyud ka buok ang iyang kinahanglan, no? It is the phosphoric acid and heat. Okay, take a look, no? This is our OH, no? So, what is the adjacent of the OH? Diba? Pwede na siya, na, diba? Pwede kani. Na? Pwede po kana. Okay, so duha na to. So if we will have it here, kani kani, then the adjacent is ngania. Therefore, that is your one hydrogen here will combine with your OH to form H2O. So you will have CH3, CH na lang because you get one hydrogen. Therefore, it will be double bond. No? Then this CH, then CH3. What is this? This is 2-butene. The other way around, you have that is na nganhi apod, no? Adjacent kani, di ba? Ang adjacent ani nganhia. Okay. Therefore, you will have here, no? What does it mean by this? Ingon sa sulti, the alkene having the greater number of alkyl groups on the double bond generally predominates. Mas na tendency nga mas kani ang mahitabo nga product. Okay, so this one which has a greater alkyl groups, kani siya, no? Greater alkyl groups. Therefore, it is 2-butene, 80%, kani 20%. Meaning this 2-butene will predominate in the product. Okay, according to this rule. So, these are example of an acid catalyst dehydration. First is 3-methyl-2-butanol. Okay. 3-methyl-2-butanol. Let us have this first. Okay. So, what will happen? Here. Muna ni siya. 3-methyl-2-butanol. Okay. We will have two product here. Then let us identify which will predominate. Okay. We have the OH here, no? Kani. Unsa ang first adjacent sa carbon? Kani nga di ba? Meaning your OH here will combine with H here to form this CH3, C, then with a substituent up, then double bond CH, CH3. Okay. This is 2-methyl-2-butene. Okay. Then the other one, this one, which is adjacent kanis picas. Okay, so makuhaan ni siya og usa ka hydrogen combines with the OH and this will form now this 3-methyl-1-butene. Okay, which will have more alkyl group. This one. So therefore, this one is the major product than this. Okay. The second one, that is letter B. Okay, 2-methyl cyclopentanol. Okay, here. 2-methyl cyclopentanol, this is it, no? So what happened? You will have two products, okay? So here, your CH3, this OH. Ang first one is kanikwaan og hydrogen. No? So mag-double bond ka nga that is 1-methyl cyclopentane. The other one is adjacent to this, kani. Sapod, no? Kani ang adjacent, nganha o nganha. Okay. So this is 3-methyl cyclopentane. Therefore, this will be the major product nga naman mas daghan two alkyl groups. No? This is, it has 3 and 1-methyl cyclopentane. Pila ka alkyl groups? There are 3, no? Groups. While this one has only 2 alkyl groups. Okay, so this one will be the major product. No? That is for dehydration. Dehydrogenation. Okay, so this will be an assignment again. Okay, no? So we have studied that. Take a look. No? It is reversible. No? Hydration and dehydration. An alkene added with water. What's the process? Hydration. you will form an alcohol. I repeat, an alkene added with water. What's the process? Hydration. And you will form an alcohol. An alcohol, okay. No? An alcohol, what happened in alcohol? If you are going to take out water, you are going to form water, no? In the process of dehydration, meaning you take out a molecule of water, no? You will form water, of course, and an alkene. No? So that is reversible reaction of hydration. That process there is hydration. Going back to that is the dehydration. That is reversible. So according to Le-Chatelier's principle, large amount of water na, will always favor alcohol formation. Whereas scarcity, na, gamay, gamay reg water or walay water, using concentrated acid, na, this will remove water. Na? And that is what is meant by dehydration. Adding water, hydration. Getting out of water, it's dehydration. So, some more example for catalyst of dehydration of alcohol and hydration of water here. No? A and B. No? So, what happened here? That is OH. No? So, what will happen? Kani mo asa mo cleave ngan he adapted. No? And you will form here this compound. Then this one, compound A, with sulfuric acid, you will have this. Okay, that is catalyst dehydration. Example for this, here, we have 3-methyl kani, 3-butanol. No? 2-methyl, I mean 2-butanol. No? Dili ta mag-carbon 1 nga niya, kay ano mahimong 1, what will happen to your OH? It will be mas malayo. 1, 2, 3. Kana. Pareho ra sila, 3. Pero nga niya, what will happen? Your substituent, this one, will be at carbon 4. So, mas duol ni siya, kay nga naman, your substituent is at carbon 2. Okay. That is why we use 2-methyl-3-butanol. So, same thing with sulfuric acid and dehydration process. Okay. What happened is, asa mukuha og OH. Okay. This is our OH. Okay. Adjacent to this is kini. Dili kana. Na? Dili kani. This one. Therefore, this will form into 2-methyl-2-pentene, which is the major product of this reaction. And of course, water. Okay. And another example, the acid catalyzed addition of water with 2-methyl-2-pentanol, this one, and you will have this product, compound B. Kani, no? Ang adjacent ani, kani, no? Ang adjacent ani is kana. So, what will happen? Because it is with water, no? With water, this OH here will cleave nga niya. Then hydrogen will cleave to that one portion there. Taking out now your double bond. The first one is, kani is dehydrogenation. This one is the what? Hydrolysis. This one is hydrolysis. Hydration. Wherein water is being added. Can you still remember the Marconic capsule? Ma'am, nga nungan hi aman siya mo cleave. instead dili ngan haa, no? Diba? Can you still Markovnikov's? The richer gets richer. So kani nga ni mo ibutang ang usa ka hydrogen instead ngan haa. Diba? Okay. So that's it. So this problem more, no, will be added as your assignment. So the next reaction is the oxidation of primary and secondary alcohol. Okay. Oxidation na ta. Kanina kay dehydration o hydration. Okay. The primary alcohol can be oxidized to form ingko sa inyo aldehyde or to carboxylic acid depending on experimental conditions. So kanang letter O nga mabutang sa process sa reaction, meaning it is an oxidation reaction. Okay. Take a look. This is a primary alcohol. With oxidation process, the O there, you will form into aldehyde. Further oxidation, further oxidizing this aldehyde will form into carboxylic acid. Remember, huh? Primary alcohol, once it is oxidized, its first product will be an aldehyde. If you're going to further oxidize it, it will form into a carboxylic acid. So, what is the common reagent? It is the potassium dichromate, K2Cr2O7. Of course, this should be dissolved in sulfuric acid. Okay. For instance, we have here, now that is 1 octanol, this one, added with no, potassium dichromate and sulfuric acid. What will happen? You will form an aldehyde muna. Okay, where is it? This OH here. No? So what happened here is kaning CH nga ni kani. Na? What will happen? Kaning na kani nga ni you will have now the makuhaan niya siya H2. Kani. Makuha H2. No? H2. Wherein, what will form is your aldehyde. Makuha ang H2. Kay oxidize man. Na? Oxidation. Na? So your H2 will be taken out. Okay? And you will form here C double bond O then H. Okay, here. Further oxidizing it, what will happen? Na? You will add on an oxygen. Na? What will happen here? Kani oxidation man reaction, di ba? Kani sakta. Na oxidation and reaction, meaning na kay oxygen, no? Meaning kaning OH ni mo og hydrogen nga ni makuha as water molecule. Did you get it? Kaning OH ni mo nga ni og hydrogen nga usa makuha as water molecule. Because this is oxidation, man siya nga ni your oxygen here will cleave to that. Okay, gets nyo? To form into C double bond O then H. You have already a molecule of water here. Then, further, oxidizing it, nag-add on na po kag oxygen, you will have another oxygen. Here, to form C double bond O then OH. It is now a carboxylic acid. The first one is an aldehyde. The second, in the second oxidation reaction is forming into a carboxylic acid. I repeat, oxygen ani added because it's oxidation. Therefore, your OH of H makuha in a form of water. Then H na lang ni, di ba? H na lang ni nga ni anabilin. Your oxygen will cleave here to form double bond O, then H. Then further adding with oxygen, with the oxidation process, oxidizing agent, oxidation process, not oxidizing, oxidation process, wherein your oxygen again is add here to form into C double bond OOH, which is an acid. So this is one octanol. Here it is an aldehyde octanol. Then this one is an acid, octanoic acid. Okay, that's it. So although the usual product of oxidation of primary alcohol is carboxylic acid, it is often possible to stop, no? Na siya'y, what you call this, first phase and second phase. Ang first phase niya will be, it will have this aldehyde transformation stage. Then finally, it will be converted into a carboxylic acid, na? If it is a primary alcohol. Okay. How about if it is secondary? Dumduma ha? Kung primary alcohol gani, ang first stage will be kung oxidation reaction gani, no? It will form into an aldehyde. Then further, no, oxidation process, it will form into an acid. For the secondary alcohol, no, you have here the 2-isopropyl 5-methyl cyclohexanol. This is known as the menthol. Kanang ginabutang bitaw sa mga candies nga ment. Okay, that's it. That's menthol. When you add this, asa dapit naangan ni ang, this is your OH, no? And this is 1, di ba? 1. Dumduman ninyo ha. Asa gani ang OH that will start with your counting of carbon 1. That's carbon 1. Then followed by carbon 2, 3, 4, 5. Mao ng 5 ang methyl. 2 ang isopropyl. Okay, did you get it? Okay. With the presence of potassium dichromate, secondary ni ha, secondary alcohol, and sulfuric acid, what will happen? This will form into this one, a ketone. Like siya, no? The primary, it will form into aldehyde, na? Basta oxidation process, aldehyde, then further oxidizing it, it will form into a carboxylic acid. Ang secondary, once it is oxidized, the oxidation process, what will happen? With your potassium dichromate as oxidizing agent and the presence of sulfuric acid, what will happen? This will form into a ketone. Okay, so that is now 2-isopropyl 5-methyl. It is no longer cyclohexanol but cyclohexanol. And this is our menthol. Okay, menthol. What are menthol? Menthol are secondary alcohol present in peppermint and other mint oils used in liquors, cigarettes. Mabito lami ingon sila lami cigarette kaya naman bugnaw daw sa because of the menthol. Okay. Even in cough syrup, they add on a menthol. Dili yun ingong kuan nga ang cough syrup na ay menthol. Ginabutangan. Why? Because this will also give a freshing, di ba? Freshing taste, after effect. Okay. In the perfume also, in the nasal inhalers, and that is menthol. Okay. Methanol, that menthol is also used as in the perfumes and artificial flavors. That is a ketone. Okay. So, more example of oxidation of alcohol. First is 1-hexanol. What is 1-hexanol? This is a primary alcohol. Here. That is it. No? Of course, unsa may product nimo ani? Basta primary gani. Unsa to? Una, mahimo siyang aldehyde. So it will be hexanol. Further adding or further oxidizing it, it will be in a form of an acid. It will be hexanol. But if it is secondary, this letter B, that is 2-hexanol, this will form into a ketone. Okay, so from hexanol to hexanol, it will be in a form of 2-hexanol. That is for the primary and the secondary alcohol in the oxidation process. Okay, this will be an add-on in your assignment. Okay, here. So let us have some what call this information about our alcohol. No? We have the breath alcohol screening. What is that breath alcohol screening? Actually, this is being used for, especially in US, if they want to know if the driver is under the influence of alcohol. They use a breath alcohol screening. The breath alcohol screening is kaning anesthesia. Okay, it is a tube wherein ang sulod ani is a potassium dichromate sulfuric acid coated silica gel na here. So ipag-blow sa tao nga niya katong the one who drives, then nasimhutan sa police officer nga murag nakainom. Okay, so that you could not say nga wa mo ko kainom, sir. Okay, in US what they did is they have this breath alcohol screening. Sige, soyop ane. Okay, what will happen? Pag blow niya, this color here is an orange. Kani, this one. Okay. This is dichromate ion, the reddish orange, no? In the reagent, it will turn into green. Basta na ay present sa alcohol. Take a look. Here is the reaction. It's ethanol. Kani, ethanol, no? With potassium dichromate, a reddish orange. What will happen? This will give you acetic acid and the chromium ion. Kani ang chromium ion, this will signify if and when you have ingested alcohol. No? Kani. Pero kung wa ka mo ingest of alcohol, this will not form. Kaning chromium ion, nga in green, this will not form. Okay. So, that is it. Napo the HCI, no? Napo the HCI, what you call this? This alcohol, no? And the reaction with dichromate, no? It has its effect in a way that this could solve if and when the person driving is under the influence of alcohol. What happened? Mo taas gani this one here, mo green gani siya taas, meaning taas pod ang alcohol content nga imong nainom. Pero kung wa gani alcohol content ang imong giinom, this will not turn into green. Okay, so that is what is meant by breath alcohol screening. Okay, so what we are now finished. We are now done with alcohol. Now we are in the ethers. That is alcohol, ethers, and the thiols. What are ethers? Okay. So ether, a compound containing oxygen, meaning your oxygen atom is at the center. That's duha dayon ka alkyl group at the side. Okay. So here, Tanisha, it's methyl, and this is another methyl, and this is your oxygen. As I have said, oxygen atom is at the center. It is now an ether. Okay, here, that's it. This is its molecular form. Okay. So This is named as pila ka ether, mga bata, duha. That is dimethyl, pila ka methyl, duha. This one and that one. Na? Therefore, the name of that is dimethyl ether. Na? Or it has a formula of CH3OCH3. Na? This is its Lewis structure using the ball and stick model. Okay. How are we going to name the ether? Now, common names are derived by listing the alkyl groups bonded to oxygen in alphabetical order and adding the word ethyl. Alphabetical order, mga bata, ha? Then the word ether. Now, alternatively, one of the groups on oxygen is named as pwede po alkoxy group. Alkoxy is the OCH3 group. For example, the methane, di ba? Methane mani with O, the alkoxy, therefore that is coxy, di ba? Methoxy, methane, then oxy. No? So that is methoxy, which tells us that the O is bonded to your, whether it's on the left or in the side with your oxygen. Okay, here, no? Okay ra og pareho, both sides. You can have the die. Pero kung dili gani, you will be using this alternative one. Na? Nga ang usa ka group butangan nimo og oxy. Ethoxy, methoxy, no? Butoxy. Like that. So here it's easy because both sides are ethyl. This is ethyl and this is ethyl. All you have to do is how many ethyl? Dimethyl and ether. That's the name of this. Here, you already know that this is cyclohexane. Na? With our methoxy, na? Or methyl ether. Na? This is cyclohexyl methyl ether. Or it is isa ni siya methoxy cyclohexane. Pwede ra. Pareho ra na siya, correct gihapon na siya. Na? If you are going to name this as cyclohexyl kani imong gikuan. Cyclohexyl kaning first group is a cyclohexyl, second group is a methyl, then ether. Ether. So it's cyclohexyl methyl ether. Or kanig kuhaon nimo as an alkoxy group. This is methoxy. Then this one is another group, cyclohexane. So it's methoxy cyclohexane. That is in the naming of ether. So here, example for this. Na? This one is, kani unsa ni siya? Another R group. This one is another. This is your ethyl. This one is, what is that? It is the tertiary. Okay, this one. This is tertiary butyl and this is ethyl. So you can name it as tertiary butyl ethyl ether. No? Tertiary butyl kani. Then sa other side, we have the ethyl. Then ether. Kani, it's easy because this is what? You can have here, this is diba? This is cyclohexane. Na? So you can have dicyclohexane ether. Okay. You have two cyclohexyl groups. So dicyclohexyl ether. Okay. Dili, dicyclohexane ha, dili. Dicyclo, it should end with YL na. Okay, because these are now the alkyl. Na? Kani nga mga side gani ay are first alkyl group. This second side here is the second alkyl group. Same thing here. This is the first alkyl group, the second alkyl group. That is for ether. Again, I will have this as your sample assignment. Let's have one of the uses of ether, okay, for you to know what are ethers. Last time, we have sa to katong sa alcohol, the breather. Okay, the alcohol breather. Kanipod is chemical sterilant. What do you mean by chemical sterilant? Mga sterilizer. Okay, so ethylene oxide is colorless, flammable gas with boiling point of 11. Tama, 11 degrees centigrade. Okay, so this one here, no, that is an ethyl oxide. No? Ethylene oxide reacts with amino, the NH group, and the sulfahydryl group. This is this one, no? Reacts with the amino, no? This one. This is now your oxide, ethylene oxide. Kani ang mao imong ethylene oxide. This one is the amino group. This one is your sulfahydryl group. And no, at high concentration, what happened? Okay, this will cause death in microorganisms. That is when this ethylene oxide is used as what? Fumigants in foodstuffs. No? Fumigant in foodstuffs. What happened? Dili mo duol ang mga microorganism kay ngano man. This will cause death sa ila. So this is used also as sterilized surgical instrument. So this is add-on, surgical instrument aron walay walay along the way pag opera walay mga microorganisms nga mutapot sa mga what call this? Sa mga instrument. So these are used as sterilizer. Add on to the sterilizer. It is ethylene oxide. Okay? So that is cyclic ether. Mao ning ethylene oxide kani. Ethylene oxide kani. Ethylene oxide, an ether in which an ether oxygen is one of the atoms of the ring. And this one is the tetrahydrofuran. Later on, you will know this in the biochemistry. This one, okay. So what are its physical properties of ether? Ethers are polar compounds in which oxygen bears partial negative. Same thing, ano man, kay naman ang presence sa oxygen and hydrogen. No? However, only weak forces of attraction exist between weaker compared with alcohol. No? In pure liquid. Consequently, the boiling points of ether are close to those of hydrocarbons. So mas taas ang kuan sa alcohol, boiling point compared with ethers. Ang ethers, it's almost the same with the alkenes. Okay, take a look here. Here, so this is a dipole-dipole interaction. Okay, one of the importance of ether in the industry is the anesthesia. No? Ganina sa to, it's used as fumigants. Chemical sterilant. Fumigants also. Here, it's the anesthesia. Ethers are anesthesia. You have here, what happened? It was Joseph Priestley who isolated this nitrous oxide, which is present in the ether. Okay, so it is being used in 1854. The first American dentist who used this nitrous oxide in dental practice. Pero sa may nahitabo, pag mata, gamay ra siguro dosage. Pag mata sa iyang pasyente, unsa man, prematurely awakened. So, siyempre, kay giibot nimo di sakit kaayo, arang syagit. So, what happened? Uy, kaluoy po niya, he withdraw from practice and become embittered and depressed and committed suicide at the age of 33. That was Horace Mills. In the same manner, Charles Jackson, he used an anesthesia from ether, that is the diethyl ether, in the dentist, in a dentist application also. Okay, so the operation was completely successful and soon generally anesthesia by diethyl ether becomes routine practice for general surgery. So mo na, it was walang unta sa sikuan, si Horace, nag-delve pa unta siya into another, what you call this, addition of it. Kay, sayo naman kayo siya good kung ano, hing bigay, no? He should go on and search on top pa. Napatyan man gud siya. Now, that is why na-depress siya. So, it was Charles Jackson, na? He persuaded a dentist, John Warren nga, gamito ni siya. And it becomes successful. So, until now, that diethyl ether is used as anesthesia. What happened nga naman? This will relax, this will, easy to use, and it will relax our muscle. And gamay ra gyud siya og effects sa blood pressure, pulse rate, and respiration. Gamay ra, slightly affect. So diethyl ethers, unsa ra may iyang drawback? Unsa may iyang one of its side effect? Sometimes it will irritate in the respiratory passage, and after effect is nausea, meaning magdigwa. Pero okay ra, no? Okay. So, nakaroon mga inhalation anesthesia, kanang simhot lang. Okay, like that. No? So, what are these? These are now your important halogenated ethers. That is the ethylene and the furane. There's one, this two. So, that is example ethanol, and this is an ether. This is an alcohol and ether. Okay. So take a look at the boiling point. Layo kayo, no? Boiling point and is 78. This one is negative 24. Why? Because two compounds is due to the presence of the OH group. Kani walay OH. Kani naa. Hydrogen bonding. No? That is why this has a higher boiling point compared with this. So ethers are more soluble in water than hydrocarbons. Pero mas soluble pa yun ang alcohol compared sa ethers. So if you are going to compare the solubility, alcohol, then ether, and alkane, like that. So the reaction of ethers, the first reaction of ether is ether resemble hydrocarbons in the resistance to chemical reaction. So most of it do not react with oxidizing agent. So and di po sila pwede sa reducing agent. So what happened in most cases, reaction of ethers is least. Lisod kaayo siya i-react with other compounds, okay, solvents. Okay. So what are the structures and names and properties of thiols? We are now in thiols, this third one, under alcohol, ethers, and thiols. Thiols is with the presence of the SH. Okay. Pareho rin siya sa alcohol, pero instead of OH, it will be SH. A compound that contains SH, that is the sulfahydryl group, bonded to tetrahedral carbon atom, like that. Diba? Kung alcohol, OH ni siya. Pero kung thiol, it is SH. Like that. So this is, paano nagyapon niyo? Diba? This is methanol. If it is OH here, it is methane thiol. Okay, the name of that is methane thiol. So this is the ball and stick model of methane thiol. So the name here, the nomenclature is sulfur analog of alcohol is so-called thiol. Thi from the Greek thion, and sulfur or older name mercaptan. Sometimes we can use that mercaptan. Mercaptan is the short way of saying it as capturing mercury or mercury capturing, mercaptan. So the IUPAC system in the name of thiols are, you select the longest carbon chain that contains the SH, then group as the parent alkane. To show that the compound is thiol, you add the suffix thiol, not to the parent. Okay. Of course, the parent chain is numbered in the direction that gives SH, the SH lower number. So the common names for simple thiols are derived by naming the alkyl group bonded to the SH. Pwede po adding it with the word mercaptan. That's the common. Na? Diba? This is 1, 2. It's ethane, but it is not OH here. It is SH, meaning ethane thiol. Or this is ethyl mercaptan. This one, no? This is 1, 2. That is 2-methyl, 1-propane thiol. Asay mong SH na asa 1. What is your parent name? It's propane. That is why it's so called 2-methyl, 1-propane thiol, or that is isobutyl mercaptan. Some more example. This one. This is 1, 2, 3, 4, 5. Okay, it's pentane. So where is your SH? It is in 1. Therefore, it is 1-pentane thiol. This one, this is, do not have this as carbon 1, instead carbon 1 nga niya. Carbon 1, 2, 3, 4. It's butane. But your thiol is in carbon 2. Therefore, that is 2-butane thiol. Okay. Or you can have this 2-butane thiol or sec-butyl mercaptan for its common name. This will be add on to your assignment. So the most notable property of thiols are low molecular weight thiols. They are responsible for kind of mga baho-baho. That's thiol. That's sunk. Sunk. The sunk is katong mga murag porcupine gyapon na siya nga dagko mo ana. Okay, baho nga mga this is family of rats, family of rabbits like that. Then rotten eggs, kanang itlog na bugok. Then the sewage, the sewage. The scent of the sunk is due to the primary to two thiols, presence of two thiols. Kani mo ni siya. Two thiols. This is 2-butene, 1-thiol, kani 3-methyl, 1-butene thiol. Kani ang duha ka thiol which is present in this mga baho, the sunk, the rotten egg, and the sewage. Sewage. Okay, that's it. The scent of this one is a mixture of mixture of these two. Manang ayaw mo baho-baho. Kaya nga basig ingon sila namoy mga thiols nga compound. Okay. Kani bitaw nga ni sa atong likod sa atong kaning di madugay-dugay tagligo kani sa likod sa atong dunggan, What will happen is mubaho siya, It is the caproic acid, Mao nang murag baho bitaw sa kanding. Manang ligo gyud mo. Ana. Okay, that's it. Okay. So what are its physical properties? Because of the small difference in electronegativity, kadumdum pa mo sa inyong Chem 16. Sulfur and hydrogen, your electronegativity of your sulfur is 2.5. Electronegativity of hydrogen is 2.1. Then subtract this, it's 0.4. Therefore, diba naman ito classification? Kung 0.4, it is a non-polar covalent. SH, what kind of a bond it is? It's a non-polar. Yeah, because of this lack of polarity, thiols show little association with hydrogen bonding. So consequently, they have lower boiling point and are less soluble in water. Kaya nga naman, it's not associated with hydrogen bonding. And this one, take a look. Compare agad nimong thiol, ethane thiol o dimethyl sulfide, ubos ang iyang boiling point. Okay. So what are the reaction of thiols? Okay. So thiols react with strong base such as sodium hydroxide to form thiolate sulfate. Na? Kay weak acid man siya. So sa strong base siya mo react. So for instance, we have here the ethane thiol with sodium hydroxide. What will happen? This will form into thiolate sulfate. That is sodium, ethane, thiolate, and water. This is sodium and this is ethane thiolate. Na? If we are going to compare now, na, alcohols, the three thiols and alcohols, this is methane thiol, na, ethane thiol, butane thiol, methane 6, boiling point 6, 3598. Na? Pero ang alcohol tanawa, mas dagko ang boiling point. Nga naman, because of the presence of hydrogen bonding and heat. Na? Okay. That is in the reaction of thiols. So, the most common reaction of thiols in biological system is the disulfides, the SS. Dua ka. Disulfide, dua ka S. Na? Thiols are readily oxidized to disulfides by molecular oxygen. In fact, they're susceptible to oxidation. They must be protected. No? Dali siya madaot. Dali siya mapanos. So, kinahanglan yun na siyang i-store. No? With air. No? So disulfides in turns are easily reduced to thiols using some reducing agents. So this is a thiol. No? By means of oxidation, it's reversible reaction. Using oxidation reaction, what happened? This will form into disulfide. And disulfide, by means of reduction, it will form into thiols. Okay. What are most common commercial alcohol? No? Of course, we know, no? The one which is no, derivative, no? That is the byproduct of petroleum, the natural gas or coal, which is non-renewable resources, no? Which is the isopropyl alcohol, di ba? Okay. Second, many are themselves starting materials for synthesis valuable. What are these are importance of alcohols, no? Una is, no, derived, no, derived from petroleum, natural gas, or coal. Pero mas lami unta ang natural gas, no? All are non-renewable. But later on, if we will have the renewable gas, no, resources, mas maayo. No? So, second is no, the no, valuable commercial products in the byproducts in modern industrial society. Okay. One is the methanol. What is methanol? So methanol is derived by heating hardwood. That is why methanol is known as wood alcohol. Okay. So today methanol is obtained entirely from catalytic reduction of carbon dioxide. Okay. Then methanol in turn is the starting material for preparation of industrial chemicals such as acetic acid and formaldehyde. Formaldehyde is formalin. Acetic acid is what? Suka, no? The glacial acetic acid. Not only kanang suka, but it's the glacial acetic acid. So the coal and methane, no? Carbon monoxide, the methanol, you will form this by means of catalysis. No? Catalysis, you will form acetic acid by means of oxidation process. This is the catalyst or catalysis reaction. Formaldehyde, it will form formaldehyde. So the bulk of ethanol, of course, is taken from the natural gas. As I have said, the difference between uh, ethanol and isopropyl alcohol is different. Katong kag ethanol is fermentation from sugar cane. Okay. While isopropyl alcohol is coming from the byproduct from gasoline. Okay, that's it here. So runs ethylene by means of this is, what is this? Alkene, and the process is what? No, process here is you are going to add it with water. That is, you will form ethanol dehydration. Okay, dehydration or dehydrogenation. Here, you will form ethanol. Here, by means of oxidation reaction, you will form an oxide. And finally, this will form into diethyl ether if you are going to have the acid, acid catalysis. Same thing here. Your oxide here will form into ethylene glycol. Mag-differ yun siya o ang process almost the same, pero it will differ in its reaction, in its product. Okay, so that's acid catalysis dehydration of ethanol. This will give diethyl, which is important solvent in industry. Then ethylene is also starting material for preparation of ethylene oxide. Okay. So what is this ethylene glycol? So ethylene glycol is the major component for automobile antifreeze. Antifreeze. Ethylene glycol freezes negative 212. Kay, kung wala pa ning ethylene glycol nga add on into the automobile, what will happen? Dili kadagang layo ang imong automobile. At kung saan may tabo, mubukal na nga to sa iyang turbines. And what na? Mag-aso-aso na dayon. But because of this antifreeze, na po'y na po'y di mo ma-anti-knocking. Nahi po na siya. So, these are products of chemistry. So, the ethylene glycol is the major component in the antifreeze for automobiles. Okay? So, isopropyl is the rubbing alcohol. It is the hydration of the propene. So, see, it is an alkene. And glycerin is a byproduct in the manufacture of soap. Without glycerin, what will happen? Dili ta kahimo og soap, dili pud ta kahimo og shampoo. Okay, like that with the glycerin. So that is it. That is in the propene. This is 3 steps. Propene. First step is it will have usa sa mga product of a propene by means of several steps that will be converted into epoxy glues and resins. Okay. The second one is this will be converted into isopropyl alcohol. And the last step is this will be converted into glycerin or glycerol. That is the importance of glycerin. Okay. So that ends our lecture on alcohols ethers, and thiols. So I hope you have gained knowledge on the naming, no, the sources, and at the same time, the reaction of these three functional group of alcohol, ethers, and thiols. Thank you for listening and keep safe, everyone.